Hi, my name's Alex Whittles. Warm welcome to this session on an introduction to Microsoft Fabric. My contact details are on the screen. Any questions you have that we can't cover in the session, please feel free to drop me an email or a tweet. A bit about me before we start. I'm on the organising committee for the SQL Blitz conference, which is running in March in the UK in Farnborough. I've got a master's degree in BI. I run Purple Frog, a Microsoft BI consultancy. I'm a data platform MVP, and I also run Power BI Sentinel, which is a software as a service platform for auditing, governance, disaster recovery over your Power BI estate. So what are we talking about in this session? What is Fabric? You've heard a lot about it, and you've probably seen a lot of marketing slides from Microsoft, such as the one on the screen, where they show everything all in one place, all of your data engineering, data science workload needs. Well, don't we already have that in Synapse Analytics? That was the combination of everything being in one place, one portal to do all of your data engineering needs. So why do we need Fabric instead? And what's going to happen to Synapse? In a lot of the Microsoft marketing slides, you will see Synapse, like in this slide, as part of Fabric. What does that mean? Well, to understand the purpose of Fabric, we need to really look at the pros and cons of not just Synapse, but also various other competing tools. Now, I will stress this slide is very much my personal opinion. Everyone's got their own perspective on the good, the bad, and the ugly for all these different tools. But to run through a few of the core. Synapse Analytics is a phenomenal platform for data warehousing, data lakes, scalability, data factory pipelines, integrated browser development. It's a very, very powerful tool. And when you look at things like dedicated SQL pool, the scalability of that is phenomenal. But it's very complex to implement. Quite time consuming to get the data modeling, the distribution right. You can end up with a model or a system that's very highly targeted towards one certain type of workload that suits the distribution of your data, but not very well suited for other type of analytics. So it can be very difficult to tune performance for all workloads. It can also get very expensive when you start scaling it up. On the other hand, you look at Snowflake. Great for data warehousing, very fast, no optimization required. It's just plug and play. You throw data at it, it's just going to work. Got time travel, phenomenal capability for rewinding and seeing what your data was last week, last month. But it's very expensive. Very limited tool set. It's one tool. You've got to have lots of different tools to make it work. So yes, it ticks a few boxes, but it's not a complete platform. You look at Databricks, phenomenal power in the Spark engine. You've got to know how to use it, got to write a lot of code. It's not a low-code environment, very scalable with notebooks, but not flexible in terms of how you approach it and different ways of managing your data environment. You've got to manage your clusters, limited reporting capability. Not really suited to data warehousing, more suited to data lakes. And then you've got Power BI, which is fantastic for reporting. It's great for scalable data sets. Virtually every organization you go to has Power BI already embedded in the organization. But it doesn't have data warehousing and data lakes. Yes, there's data marts, but quite frankly, no. And so it really is just there from a reporting perspective. So if we look at all of these different options, and there's plenty more out there as well, if we look at all the good features of them, can we find a way of actually taking all of those really powerful features and combining them into a single platform that gives us everything we need without all the negatives? And that is Fabric. Microsoft have looked at the positives of Synapse, the things it does well. They've looked at Snowflake. They've looked at Databricks. Brought all those really good features together and combine them into one unified platform. And for once, this really is a unified platform. It's not the semi-unified platform that the Synapse promised us. So within Fabric, we have data warehousing, we have data lakes, we have Spark, we have data factory pipelines, native Git integration. It is very, very scalable. And it combines the power of Power BI. All of this sits within that existing Power BI environment that we like. It brings in all of that power of things like notebooks, the storage formats of Parquet, Delta, etc. So within the core of Microsoft Fabric, we have the two core elements of primary data storage, your data warehouse and your data lakehouse. Critically, though, a data warehouse is not SQL Server as we know it. It has a SQL Server compatible interface. It may look like SQL Server when we connect to it and query it from Management Studio or Azure Data Studio. Behind the scenes, the actual storage layer has been completely changed to use OneLake. OneLake is the storage layer that underpins everything in Fabric. It is based on Azure Data Lake Gen 2 with the Parquet Delta file format as the standard storage across. So whether you choose to create a data warehouse or a data lakehouse, a Delta Lakehouse, or just a data lake, it's all using this OneLake storage. And when you look at Power BI workspaces, whenever you create a warehouse, lakehouse in any of your workspaces, as a tenant, your entire organization shares that same OneLake, but in divided up, controlled, securable components. So how do we get data in and out of this system? What's our ETL tool and our querying tools? Well, to get data in, you can use SQL, you can use Spark, you can use data flows, you can use pipelines. They all connect into these. Whether you have a warehouse or a lakehouse, the interface and compatibility is very, very consistent, but there are differences which we'll get to in a bit. You can run your ML workload in Spark against your OneLake data in your warehouse or lakehouse. And then you can get data out of it through SQL, through Spark, through Power BI. Because it has a SQL interface, anything that can connect to a SQL interface can query either your lakehouse or your warehouse. So there's a lot of compatibility and standardization between the warehouse view of the world and the lakehouse view of the world. So one of the common questions we get is, which one should we choose, a warehouse or a lakehouse? If they use the same storage, the same file formats, what's the difference between them? And that really comes down to what your tool of preference is. Are you more of a SQL person or more of a Spark person? That's really the primary choice here. And that's down to how you want to write data into your Fabric warehouse or lakehouse. You can use data flows and pipelines for either of them. That's fully compatible. If you're more of a SQL person and you want to write queries, you want to be able to write update queries, insert queries, delete queries, then you will need to use a data warehouse because the SQL endpoint for your data warehouse is fully ACID compliant, read write. You can do everything you want to do in your data warehouse using SQL or pipelines or data flows. If, however, you want to use, you're more of a Spark person, you want to use notebooks and PySpark and that sort of things, then the Lakehouse is going to be your preferred tool. The Spark engine or the notebooks is going to be your primary method of writing into that Lakehouse, alongside obviously your data flows and pipelines as well. Now, as I mentioned earlier, you can still query your Lakehouse using SQL. You can still query your warehouse using Spark. So there is a lot of compatibility there, but it's really about how do you want to insert, update, manage that data, and which is your tool of choice. So the choice between a warehouse and a lakehouse isn't quite as simple as just those two options. There are more as well. And this is a cheat sheet that we've put together that gives you a high-level overview or a kind of comparison against what the primary purpose is of all of these different features. So we've got a data warehouse, fully ACID compliant, everything you want to do, similar in functionality to SQL Server or Synapse dedicated SQL pool. This is currently in preview and it'll be going generally available hopefully soon. You can write to this using SQL, data flows, pipelines, etc. The primary functionality, it's got tables, SQL Server views, store procedures, functions, and all of those are read-write. The data mart, you already have a data mart in Power BI. That data mart is going to be, at the moment it uses Azure SQL DB as a storage. That is going to change. That is going to migrate into a smaller form of the Fabric warehouse, just with less guardrails and protection in place. It's a more easy departmental warehouse for smaller purposes. That is going to be it's already available, but we're not sure on the date yet when it's going to migrate into the OneLake warehouse storage format. Lakehouse is for unstructured, semi-structured. Even with semi-structured data, we can still treat a lot of the data as tables. So we can still query it in SQL, or you can put unstructured data in there purely as a dumping ground for data lake files. Again, that's in public preview and fully available at the moment in that preview mode. And you can use these in combination with each other. You can use a lakehouse and a warehouse together, lakehouse for staging data, warehouse for presenting it, however you want to manage that. You still get the SQL functionality of tables, views, store procs, and functions, but they are read-only. The SQL endpoint to your lakehouse is not read-write. Then we get on to mounted database, and this is not available yet. It's going to come at some point. We don't know when. And this is a change data capture system that can clone another database into Fabric. So let's say, for example, you've got a SQL Server or a Snowflake database or a Synapse Analytics database. And you want to keep that as your primary source for managing all of your information. But the reporting workload on that is causing you a lot of problems, stress, and cost in those systems. Mounted database plugs into that, creates a change data capture feed to create a real-time clone of that in Fabric. So the data is duplicated and duplicated in real time. Real time, reasonably quick. We're talking seconds or minutes, not hours or days. And that allows you to keep your Snowflake, your Synapse, your SQL Server for your primary functionality workload and offload your reporting workload to Fabric. And Fabric users can query that in a read-only way and use that for all of their querying, their Power BI reporting, machine learning workload, or whatever else you want to do for that data. So it's a way of distributing the workload across your different systems. And then finally, we have the shortcut. Now, a shortcut, similar to Mounted DB, it's for external data, but it doesn't create a copy of it in Fabric. It just creates a shortcut. Think of this as a linked server in old SQL Server parlance, where you can run a query against it. It passes that query off to the primary system and brings the results back. And it allows you to run cross-system queries between different systems, whether you've got a warehouse, a lakehouse, a mounted database, and a shortcut, one query across them all, and really you have one platform that can combine all of that together. So all of these, with the exception of the shortcut, are stored in OneLake. Shortcut's the only one that doesn't keep the data in Fabric, so that's stored in the source still. Everything else is stored in OneLake. Why OneLake? What is the benefit of OneLake, and why would we want to use, for example, a mounted DB, a shortcut, etc.? Why do we want to use Fabric to query external data? And I need to send a big shout out to Andy Cutler, another data platform MVP in the UK, who did quite a lot of performance testing on Fabric, comparing different scenarios of serverless SQL pool using data lake storage, and shortcuts and data stored natively in OneLake. There's a great blog post that he's written where you can go and look at the details, but I want to point out really this chart in the middle that compares the same workload of querying about 1.2 billion rows of data. And the first line, the first bar, is 1.2 billion rows of data stored in Azure Data Lake Storage, ADLS Gen 2, being queried through Synapse serverless SQL pool. And he ran a number of tests over this, I think 5 different queries, and the total time taken to retrieve that data across those 5 queries was about 107 seconds. Then Andy created a shortcut. So within Fabric, a shortcut to the same storage, the data has not moved, but used Fabric to query that data. And querying the same 1.2 billion rows 5 times took under half the time, 50 seconds. Then he copied the data and actually stored the data natively in OneLake, in the Delta Lake format, and then did the same testing. And that reduced the query time by over half again, down to only 22 seconds. So all of this performance is not just the underlying inherent performance of the OneLake platform, but it's also the layers of caching and optimization and how these queries are executed and run. And we can see from the second set of charts, each of the 5 queries run in turn on each of the platforms. So we can see the pale blue bar is the first run, which takes the longest in every case. Still faster in Fabric using a shortcut, and even faster using native Fabric. But the subsequent queries really show you the power of caching, both in serverless SQL pool and using shortcuts, and especially when using OneLake. That 18-second query went down to 1 second, or under 1 second for every subsequent query. So it's the inherent performance of the Fabric engine, plus the optimization of the caching, plus the optimization of how it queries external data. All of this really ties together to give you some quite impressive performance updates. Now, obviously, the system is Fabric's still in preview at the moment, so things are evolving, things are changing, things are improving. So do test this out on your workload to see if you can get that kind of performance. So one of the things we need to look at is, why is Fabric so fast? Why is OneLake so fast when it stores its own data? The difference between scenarios 2 and 3 here of actually storing the data natively in Fabric. Why is that so fast? I should mention that all of these tests are using the Parquet storage format. So it's the same Parquet file, or the same storing it in Parquet in all 3. So why is Fabric faster? What makes it so special? So first of all, let's look at what Parquet is. Parquet is an open source file storage format based on column store compression. It has become the de facto standard for data lakes and delta lakes. It's created by the Spark team, Databricks, and it is pretty much the standard format if you're using Databricks to create any kind of delta lake. So the open source nature of this means that it's the interface to it and the exterior structure of the Parquet file format that makes it accessible and open source to all systems. What other file format do we know that is very, very good at column store compression? This is a Fabric / Power BI session, so hopefully you've already guessed. vertipaq. vertipaq is as far as I'm aware, the world's fastest and most efficient column store compression tool. In terms of the internals of the compressors about 10 to 1. It is one of the core reasons why Power BI datasets are so fast when compared to other competing tools, Tableau, Qlik, etc. So it's created by Microsoft. It's a proprietary format, column store compression, and incredibly fast. The Parquet open source format allows you to change and tweak the internal compression algorithms inside those Parquet files. So what happens if we combine the open source functionality, interface, and nature of Parquet files with the internal compression algorithm of vertipaq? We end up with vertipaq, where we take the benefits of Parquet, the compression and performance of vertipaq, and we create the file format that is native to Fabric. It enhances Parquet with vertipaq technology, but critically, it maintains full compatibility with Parquet and Delta. So if we write a file to Fabric using Fabric data flows, pipelines, or notebooks, it can still be read by Databricks. However, if Databricks writes a file to Fabric, it doesn't know how to create these cool new vertipaq files. So it's going to create its version of Parquet, and that's not going to be as fast. So do be aware of that when you're creating content and creating data inside Fabric. You have to use a Fabric tool to create it to really leverage the benefit and power of that vertipaq format. In early testing, we're seeing up to 4 times compression over Parquet Delta files, with a big performance improvement of up to 10 times performance. Optimized file sizing. It's not just the content; it's also optimizing the size of the files and how data is batched up into these and segmented into the different files. That all really helps optimize the data for the Fabric engine. So what else does this vertipaq format bring us in terms of benefits? Well, if we look at what we've got inside our Fabric estate, we've got our data warehouse and our lakehouse, both of which use this OneLake Delta vertipaq format. So how do we get data out of that into Power BI? Well, it depends what we want to do with it. If we want to bring all the data out into our Power BI dataset, we put it in import mode. And so the Power BI dataset grabs the data from our warehouse or our lakehouse, brings it through into the Power BI dataset using the internal vertipaq compression format. And once it's there, it's hosted in Power BI.com workspace, and we can run DAX queries against it. So the DAX query is when we're querying the dataset for reporting. It then runs a SQL query to grab the data from the source. But the data is only as up to date as the latest refresh. So what happens if we have too much data? Too much data to fit in an import mode dataset. Or we want real-time data. Well, then we have direct query. Direct query, the dataset itself doesn't store data. It is just a layer, a semantic layer, that converts DAX into SQL. So we fire off a DAX query to the dataset, and it then converts it into SQL, fires that off to the source. In this case, it's going to be our warehouse or our lakehouse. So that's going to fire off to the SQL endpoint. So let's say we're using a lakehouse. That then has to take that SQL query and figure out which of the data points in the lakehouse it needs, and go and do a scan of all the data, filter it, bring back the results, passes it back to the Power BI dataset, which can then return the results in a nice pretty chart. One of the really interesting and powerful features of Fabric, though, is if we're using a compatible version of vertipaq to natively store our data lake and our warehouse, why can't we just run our DAX directly against that vertipaq format? If it's based on vertipaq, what's the difference between that and a dataset? And that's exactly what direct lake mode is. So every data warehouse or data lakehouse that you build in Fabric automatically has a default Power BI dataset generated alongside it. And that doesn't store any information. Think of it as like a direct query pass-through, but instead of direct query converting DAX to SQL, it's direct lake, where it just passes the DAX straight through and runs that DAX natively against the native storage of your warehouse or lakehouse in Fabric. And that means you can have whatever size data lake you want and still run native DAX against it using your direct lake Power BI dataset. Now that brings us a huge potential performance and scalability optimization of all of your data, and brings a level of performance never before seen in the Power BI world. Even with hybrid tables of direct query and import that we had before, they worked really well, but not as powerful as this. So will Direct Lake be as performant as import mode? Difficult to really say at the moment. I don't expect so. You're always going to see a performance benefit of having the data in import mode, I think. because it still has to go into the lakehouse warehouse. It's not the same as an import mode. However, it's not going to be far off it. Time will tell as we get to do more testing, more exploration of this, to really see the comparable performance in different scenarios and different types of data. But it gives us an extra option. So each warehouse or lakehouse has a single direct lake default data set against it. You can, of course, create other direct query import data sets over the top of that if you want to. So one common paradigm is likely to be design your lakehouse or warehouse with your direct lake model on top of it. Use that for your reports that really do need to scan all of your data and give you that phenomenal power over everything. You probably still want to have import mode data sets as well that are more refined, that are maybe manipulate the data a little bit and present it in a slightly different way, departmental customizations, power users, etc. It's really, we're evolving this understanding at the moment as to how that's going to work in the real world. But that multi-tier approach of still having those import mode data sets where they provide that benefit and customization, but then falling back to direct lake, for example, to avoid having to have one massive cube for your entire warehouse. You can now have your direct lake for your entire warehouse, but where you want more focused data sets, you can still do that. One of the things to bear in mind, though, is do you want people to have access to the whole warehouse? There's a lot of work still being done in Fabric. So as of October 2023 at the moment, we're not in general availability of Fabric yet. There's still a lot of work being done on the permissions, the security of the Fabric storage, the warehouse, lakehouse, and consequently the direct lake mode. So let's come back to the original question of what is Fabric? Well, it's everything. It's pretty much all the tools we need to really manage our entire enterprise data analytics and data engineering workload, all within a Power BI workspace or a Power BI tenant using lots of workspaces to manage the security, all being underpinned by this OneLake storage layer. The performance that goes with that, based on this vertipaq storage, opens up huge possibilities for things like data mesh environments that have historically been a lot more difficult to try and create, departmental data lakes and warehouses. But because they're all sat in the same OneLake, you could use shortcuts, for example, so that a lake house created by the finance team, you could create a shortcut of that into the marketing team, and they could then cross-query that lakehouse as part of their own workspace. So it opens up a lot of possibilities for managing the cross-sharing of information between departmental data marts, etc., and combine them together in ways that historically have been quite difficult to do, which is that concept of data mesh. So the big question really is, well, what's this all going to cost? How does the pricing model work with this? And there are a whole new set of tiers of pricing. Previously, we had, well, if we exclude premium per user, we had two primary methods of creating premium capacity. We had the embedded SKUs that you bought through Azure, A1 through A8, and then the premium SKUs, P1 through 5, that you bought through Office 365. With each of those, so let's say a P1, for example, this premium P1 had 64 capacity units, CUs. That was the amount of compute that was really allocated to that premium capacity, and that's what you're measured on for whether you're exceeding or under your allowed capacity. Well, with Fabric, that gets simplified a little bit because that equates to an F64. So the Fabric tiers are directly correlated to the number of capacity units that you get. So a P1 or an A4 is logically equivalent to an F64, providing the same level of power. 64 capacity units, 8 virtual cores, And the pricing here is as of a few months ago. This is pay-as-you-go pricing per hour. That's in dollars, in pounds in the UK. This is what it would be in terms of monthly. Now, that's a lot more expensive than an equivalent P1, because this is pay-as-you-go. This is billed more closely to the embedded SKU, where you can turn it off, turn it on, scale it up, scale it down as you want. So it's pay-as-you-go pricing. When Fabric goes generally available, there will be details of the reserved instance pricing, where you can reserve it in a similar way to your existing P1 through P5 premium capacity. And then you will get similar pricing. We don't yet know what that's going to be, but we expect it to be reasonably similar. Your premium capacities will be migrated to equivalent Fabric capacities. They are essentially the same thing. So they will get automatically migrated over at some point. We don't know when yet. So, do you still need Power BI Pro licenses? Well, there's a difference here, a split at this point here. From an F64 down, or from equivalent to a P1 down, no, you don't. You still need Pro licenses to create Power BI reports, but not to consume them. In the same way Premium 1 through 5 currently works. From an F32 and below, yes, you do need Power BI Pro license to consume your Power BI reports. Now, that is your Power BI reports, your Power BI datasets and reports. The Fabric data warehouses, data lakes are completely separate. You do not need a Pro license to query a data warehouse or a data lake in an F8, for example. The Pro license is just about consuming Power BI content, not Fabric. Premium per user is going to be still available, but that is really still restricted to Power BI functionality, not Fabric. So if you've got a PPU, you're not going to be able to use it to spin up a data lakehouse, data warehouse, Spark notebooks, things like that. You will have to have a Fabric instance. But then you can spin up a Fabric F2, albeit only quarter of a core, but it's 36 cents an hour. Very, very cheap. So you can spin that up to play with it, to create your basic, simple proof of concepts. And then if you want to have a PPU as well, you can do for your Power BI consumption or just your Power BI Pro license. One of the beauties about Fabric is all of the functionality, everything that we see within the entire Fabric world is wrapped up into that same pricing model. It's not like Azure, where you pay separately for your Synapse SQL pool, separately for your data factory, separately for your data lakes. Everything that you do is paid separately. And it becomes very difficult to predict what that price is going to be because it varies all the time. With Fabric, once you've purchased an F8, an F32, whatever that pricing tier may be, you get a number of capacity units. And with those capacity units, that covers all of your workload, your SQL querying, your notebooks, your pipelines, everything, your Power BI Premium functionality, everything is in that CU. So every task that you do will be allocated a number of CU seconds that it consumes. How many seconds of CPU are you consuming to run that pipeline or to populate that warehouse or to run that query? So you'll be able to see a breakdown of, in this Fabric capacity, what consumed all of your CUs and where that computer is going. And that's at a fixed price every month or every hour. And if you want to scale up for particular workloads, you're going to be able to run the extensive workload and scale back down again. The only cost additionally to that Fabric capacity, we've already talked about the Power BI Pro licenses. The only additional cost to that is your storage. So with your Fabric capacity, this is really about compute. It's your notebooks, it's your warehouse, it's your pipelines. It's not about storage. So as you put more and more data into your OneLake, you will be charged per gigabyte of storage you use. It's going to be the same similar pricing to Azure Data Lake Gen 2 storage, which, as of a few months ago, was in the region of two English pence per gigabyte, so a couple of cents, US cents per gigabyte per month. So it's quite cheap. Obviously, there's various different pricing models of that, and we'll find out more details on the exact pricing when Fabric goes live. So now that we've had a look at the theory behind what it should look like and what the purpose is, let's have a quick look to see what it looks like. So within your Power BI portal, you will have already noticed that all of your Power BI icons have gone Fabric green, but the actual URL is still powerbi.com. Within your workspaces, I've created a Fabric Frog Sandpit 2, and in this workspace, I have a lot of different bits of functionality. I've got here a data warehouse, for example. I've got, against that warehouse, I've got the default direct lake data sets that got created against it. I've got a lakehouse here. I've got the SQL endpoint against that lakehouse, and I've got the default data sets. I've got a Spark notebook in here, all sorts of things. So let's have a quick look. Let's first of all look at a data warehouse and see what that looks like. So this is loading up all of the, basically think of this as SQL Management Studio in a browser. It's loading up all of my tables on the left. I've got tables here. I've got views there. I've got functions, store procedures. I've got schemas. I've got saved queries. Within my customer table, I've got all of my data. And I can write a SQL query here of select top 1,000 from customer. And I've got an error. Why is that? Let's just drag it in there. Sorry, I didn't prefix it with the schema. Should be dim customer. And now I've got my my data. You can obviously, as you just seen, drag and drop content in here to help with these things, to help you write your queries, and that's the same in data warehouses and lake houses. How do you get data into your warehouse? Well, you can build a Dataflow Gen 2 or a pipeline. Think of a pipeline as Data Factory, and Dataflow Gen 2 is Power Query, but it's Power Query that has an output. So here we can define whatever we want in our Power Query using any sources we want. In fact, I'll just load one here that I've already got created to make it a bit easier. So let's have a look at my, there we go, data flow. Oh no, that's the one I just created. Once you've got this created, you will see down the bottom here on the bottom right, a destination of where you want to put this Power Query when it runs. That you can choose your lakehouse, your warehouse, which table it goes into, etc. I've also got a data pipeline here. Oh, there we go. There we've got a data flow that hopefully is working. There we go. So at the bottom here, we're going to our lakehouse, and we can see it's going to our dimension customer. So whenever this Power Query runs, and you can see it is the same as Power Query, it's going to populate that data in that particular table. The update method is replace, so it'll automatically do an update for you. As well as that, you've got the data pipelines, which is comparable to Data Factory pipelines for your copy data, things like that. And you'll see exactly the same or very, very similar properties to you see in Azure Data Factory. And you can nest these pipelines as well by invoking other pipelines. So let's have a look at the lakehouse now. Here we've got a lakehouse. And within our lakehouse, we can do the same thing. We can see all of the tables and also files down here as well. So here we've just dumped a whole load of parquet files. We can still view those files, or we can bring them in as vertipaq delta tables, and we can have a look at these tables. And we can get data by uploading files, creating a pipeline, data flow, create a shortcut, or we can create a notebook. If we open up an existing notebook, these are the notebooks that we've got in this workspace. So let's have a look at one of those. And you can see here we've got a standard notebook. We've got, we can choose Python, Scala, SQL, or R, and we can just play with this as per any other notebook. We can also open this in VS Code if we want to as well. So you don't have to use the browser interface. One of the beauties about the notebooks here is you don't have to worry about server clusters. There are a shared pool of clusters that when you execute this, it's going to just use one of those shared pools. So you haven't got to worry about spinning the cluster up, the cost of keeping it up and running. You can just use it and just stop. And you haven't got to worry about anything like that. Keeps things nice and easy. And the time that you use for that for that compute to run these notebooks is just taken out of your capacity units, your CUs. Let's go back to the lakehouse. One thing we can also do, if you look on the top right, we have the lakehouse mode, and we can change that to SQL endpoint mode, where we can run read-only queries against our lakehouse. So this is viewing it as if it were a database. We can create views, we can create functions, store procedures, schemas, create queries. So let's create a query. And let's bring in the fact sale. And we can run that as if it were a SQL query. And we can connect to this using Azure Data Studio, Management Studio, etc. So I mentioned previously about this direct lake mode. Well, when you want to create or create a Power BI report over this, how does Fabric know the relationship between these tables? And if you look down the bottom left, you can see this model button. And this is where we define the relationships of that direct lake mode functionality. We can hover over this and we can see storage mode is direct lake. And we can also create measures here as well. So we're creating measures directly in the lakehouse. This is still in preview. There are still a few challenges. They will get resolved. And so if we wanted to create a new report over this, we can just click New Report. And this is going to allow us to create a new Power BI report directly over that lakehouse. So let's drag on total sales. Let's say we want to view this by, let's go by city. So every time we run this, this is querying live our data lakehouse. Let's add another visual for, I don't know, let's look at customer category. That'll do. So we can then see, well, what's happening there. And that's giving us our same cross-filtering functionality that we get in Power BI. But as we're doing this, it's passing that DAX, running it through the direct lake mode dataset, running that DAX directly against our lakehouse, and caching this information as it comes back again. So the more you use it, the faster it gets. You can see now it's pretty instant. So hopefully you can see the power of Fabric, bringing all of this functionality into one. It's really about bringing all of the functionality that you want in all of your environments into this one powerful world within the Power BI interface, and combining enterprise-grade data analytics with warehouses, lakehouses, with departmental power user analytics, and a Power BI interface over the top of it. Hopefully you found that interesting. All of my contact details are up on the screen. If you have any questions, please do feel free to fire over emails. Also, there's a link to download these slides, bit.ly/MSS Fabric. Thank you very much for your time.